and enjoy the pleasant climate.
Sure.
Because it's coming out of the cold climate now. Hopefully you are of course the summer would have stepped in there, and it was a joy to have worked with Dr. Pooja Jain, and I'm happy also here to be here to share some of my viewpoints. I'm basically coming from a security perspective or an intrusion detection perspective. So that's the theme that I have chosen. But we are trying to apply various machine learning algorithms. So my forte is not specifically on machine learning, but how I've applied machine learning to many of these problems in intrusion detection. So as we look at, of course, when we look at the variety of problems, they all form into some kind of either anomaly detection or some kind of trying to find out whether there was any misuse, or is there any anomaly, or is there any variation from the actual or normal functioning. So this is exactly what we are trying to do in most of these algorithms as we look at, right? So we will try to look at, and maybe most of you are also working on the high-end aspects. But then if you look at a specific domain, right, and how do you take that further is a question, right? Many times we try to look at, I want to do research in machine learning. And if you want to really do research in machine learning, we need to really look at trying to handle a new algorithm, develop a new algorithm, or try to come up with a generic algorithm, combining multiple algorithms together, and then trying to do that. So in fact, when we were discussing with my supervisor after I completed my PhD, I worked with him for some time. So at that time when we were guiding some students together, he used to talk about, because that buzzword at that time was machine learning, and now it is deep learning. And he was a man who was teaching artificial intelligence since maybe 1990s, when the subject AI came in. Of course, now AI has become a different connotation in the sense of the Ritchie and Knight book. There's a different meaning, and today there's a totally different meaning. But of course, the concepts, the fundamentals are still the same. So as we look at this idea of trying to look at an aspect of security where there are attackers who are intruding into the network, right? So we have a source of information which is coming, which is nothing but a network packets. A series of packets are coming in from outside the network and coming into your network, right? So anybody who is handling computer networks or who has taught a subject on computer networks, you understand that packets are coming. Now, when you look at packets, they are having some data, there is some information, there is some payload, right? And based on this initial information that you can convert that payload, of course, maybe it is personal data and confidential data, but you can definitely analyze the header information. So you take all those headers and try to analyze that data. And you can come up with a conclusion whether the traffic that I'm analyzing is normal. You know, we tend to understand whether the traffic is matching a particular attack. So that's what kind of it goes into the signature detection, and whether there is any deviation from the normal traffic, right? So these are the two problems that we tend to understand, right? We know a signature, we know a problem, right? Yeah, screen is not yet shared. I have not yet started. So sometimes we are too much used to seeing a slide. I just wanted to converse first before I start sharing the slide, right? So I mean, of course, I am not able to see any of you. Only your names I am able to see. But still, what I thought was, let me just briefly introduce what I was wanting to look at, right? So the question that comes to our mind is that we will try to look at whether there is any matching with an existing attack signature, right? We know different kinds of attacks are happening, so different attacks will have a different signature, or when you talk about signature, a particular pattern, right? So that's what is a signature. So once I'm able to identify a pattern, and then if it is matching, then I will say this is an attack. I detect the attack, right? The second option is I know what a normal traffic is. Usually every day, what is the traffic? Now you see a lot of websites are being visited of the news channels, because since morning we are wanting to find out what has happened in UP, what has happened in Manipur, what has happened in Goa, right? And then we see okay, these are, so there's a huge traffic rush onto the news websites or onto Google, where searches are on what is the election results, what is the status, who has won, and all these kind of searches may have been going on. So there is usually a search, and that search is all within our country, India. Of course, maybe the other country people also, maybe where Indians are staying abroad, they may also want to find out. But of course, their time zones may be different. They may be asleep, very deep sleep now. But then yes, they are wanting to find out. Maybe so some of them are awake and wanting to search what's going on, just to find out, right? So there's a abnormal search. There's an anomalous activity that is happening. So usually these anomalous activities are related to what are called attacks. So this is a kind of background with which we start, and let us see what, of course, as our team did, and what you can do. Some of these things, maybe I just wanted to give as an encouragement, because many times we think of doing a lot of things which may be slightly difficult, but if you start somewhere, and I think those things will pick up, right? So let me just start sharing my slides here, and then let's try to look at how it goes, right? Yeah, 1 minute. फोन नंबर श्रीनिवास राव। ठीक है, मेरा टॉक चल रहा है। Sorry for this thing. Oh, I hate this. I'm not able to see the. Yeah. Yeah, we hope my slides are visible. Yes. Hello. Hello.
Yes, it is visible.
Yeah, sure. Yeah, let's. So this is machine learning and intrusion detection. This is what I want to look at. So maybe if you identify this thing where we're talking about machine learning, right? This is where machine learning is used, right? So what is this? This is, of course, just to save time. Okay, this is basically the IBM Watson computer playing the Kaun Banega Crorepati type of game, right? Who wants to be a millionaire? And then we see that it has actually won more money than both of them, right? So they are human beings who are receiving the information from memory. But here is IBM Watson. It is receiving the question from the quizmaster, searching the internet base, and then it is able to quickly answer before they are remembering from memory and answering before they are able to answer it is able to understand the question and answer fast. So that's something which is unique. And then of course you can have the Google Assistant, which again also helps you with a lot of information. You ask, hey Google, and say, then it starts off, and then of course on my mobile phone also it is starting off, because I said of course Cortana, and then of course Siri is also there. So all of these are able to actually, how can I help you, right? So they can get a lot of this information, and what are they doing? They are actually going and searching a huge amount of information and coming back with the result. So this is something which is actually happening. So when you look at the artificial intelligence, so of course there are two types of intelligence. So many times when they say, are you working on artificial intelligence, I always respond to them, no, I usually work with natural intelligence, right? So my intelligence is natural. So anyway, that's a pun, but anyway, AI is a very challenging aspect, and then we cannot ignore it, and we have to definitely take it further. So it's basically one's capacity for logic, understanding, self-awareness, learning, emotional knowledge, reasoning, planning, creativity, and problem solving. So that's where it comes from, the intelligence. So if it is natural, you have basically an inherent logic and inherent understanding. Inherently, you know what you are. You learn some things, and then emotional knowledge, reasoning, planning, creativity, it's all internal. And of course artificial also we can try to bring in this thinking. Actually, as you look at the word of trying to think, comes from these neurons that are there, and then that became the basis for our understanding of this next level of thought process, that is neural networks, which maybe you are introduced, and you may be running different RNN, CNN, and different kinds of neural networks, right? So basically where the information is stored, and how the dendrites and cell body, and where the information is stored. So this is something that we tend to understand, and how this is coming into the picture. So if you look at intelligence, it's a property and ability attributed to people, such as to know, to think, to talk, and to learn, right? So it's basically uh, people have this intelligence, and then they know something, they think about something, they talk about something, or they learn about something, right? So it's a property which is attributed to people, right? And then that same attribution is now attributed to computers, because they tend to learn, they tend to know certain things, they tend to think. And, computers can think, right? So this is the ability that human beings have try to induce into what they were trying to do, and put it there, right? So that is something. So it's basically something, something you think, something you talk about, and something that you can learn. That's the property, right? So it is knowledge, knowing something, and the ability to perceive, feel, comprehend, process, communicate, judge, and learn, right? So it basically depends upon unconscious instinct that can never be captured in formal rules. If you look at human understanding, and if you have a set of rules for a computer, it will function in the same way. And if you put the same rules for a human being, it depends on his unconscious instinct. He feels, today he may feel something different, and in the morning and in the evening he may feel something different. Next week he may feel something different. A year later he may feel something different. So you can never put it into formal rules as far as the human intelligence or the natural intelligence is concerned. And of course, if you look at intelligence, again, is of multiple types, right? When we look at, and then slightly bigger diagram, if you look at, there are spatial, this thing where spatial intelligence, world in 3D. You have a naturalist who is understanding and understanding the nature. You have somebody who is having the intelligence of music, sounds, pitch, tone, rhythm, variety of these things. I don't mostly understand that. And then there's some mathematical and logical intelligence also, right? So you quantify, you take hypothesis, you prove them. That's basically some of our researchers do this logical thinking. And then there's existential intelligence also, questions on why we live and why we die, very sometimes these things. And then some interpersonal intelligence, how you can sense other people's feelings and motives. By looking at somebody, people are able to estimate or analyze or predict whether somebody is telling the truth or not, right? We are communicating face to face, and the person is able to perceive whether you are telling the truth or not, right? Many times they call it the face reading or something. So they look at different patterns in the face or in the tone and in everything, and they're able to identify. So there may be, of course, bodily kinesthetic also. There is intelligence of how you, how maybe a karate person or a kung fu person, how he handles the body and the how he disciplines himself. So there's a kind of knowledge about the body, how flexible he can become and all, right? So, and then finding the right words to express, linguistic intelligence, intrapersonal intelligence. So, so interpersonal is there and intrapersonal is also there. So what you feel, what you want, and things like that. So a kind of so much of intelligence is there, and we are trying to only try to look at one kind of thing, but then a whole source of things when we look at this is what comes in. So natural intelligence. Moving to artificial intelligence, basically we are studying complex information processing problems that often have their roots in some aspect of biological information processing, right? So we are trying to bring it closer. Why we say artificial intelligence? Because we are mimicking the natural intelligence. You may be wondering why I am bringing all these things. Is because we are trying to look at what a human being does. We are training a computer to do. That's what is, sometimes when we say machine learning, we are training the machine to learn how a human being how a human being learns. How many human being has a certain process of learning, and we are trying to mimic that. We are trying to imitate that. We are trying to recreate that kind of thing where we are training a machine to learn, right? So of course, a variety of things, and then just like how we are able to identify a pattern, a machine is also able to identify pattern. So the words are different, but I think the concepts are all same. If you call it artificial intelligence or soft computing, data mining, or neural networks, most of these are trying to come there. Pattern recognition, right? So it's basically artificial intelligence is the umbrella that you can put all of them under, right? So that is something that you can look at, right? So basically biological information processing, how it is happening. The goal of the subject is to identify solvable and interesting information problems and solve them, right? David Marr. Artificial intelligence is a design, study, and construction of computer programs that behave intelligently, right? So what we are trying to do is we are trying to create a program. We are trying to create a software, or we are trying to create an algorithm. Okay, we'll try to design, we'll try to study, we'll try to construct an algorithm which will behave intelligently. So intelligence is what we have already discussed. So now we are trying to write a software program which behaves intelligently, right? So it is the enterprise of constructing a physical symbol system that can reliably pass the Turing test. What is a Turing test? Some of you may have actually looked at. I will show you in the next slide what is a Turing test. The science and engineering of making intelligent machines, especially intelligent computer programs. If you look at artificial intelligence, it is the science and engineering of making intelligent machines. So machines need not necessarily be physical machines, physical computer machines, but basically they are intelligent computer programs or software, right? Or the algorithms. That's what we can try to look at, right? So what is a Turing test? Turing test is something like this, right? So on one side there is a block, right? On the other side there is one computer. On this side there is one computer, and the person who is seeing is able to see an individual. Maybe a mask is there on the other side. Okay, so that's all. So this individual thinking I am chatting with somebody, right? So he is thinking I am trying to interact with somebody, right? So if you give some input here, and there is a response that is coming, but the response is actually coming from a robot, right, or a machine, right? So we can try to understand that if this person is able to believe that here there is another human being who is responding, then it is said pass the Turing test, right? Maybe if you have watched Google I/O, right? Maybe Google I/O is an annual event, and each time they come up with innovations that Google is doing, right? Or new features, new applications, new things that are happening. So every year you can watch it. Maybe it's a 1 hour YouTube video or something like that, right? And then you would have seen a Google Assistant calling a barber and fixing an appointment on behalf of some individual, right? So you can tell Google, please call my barber and fix an appointment at this time. So these are the only instructions that it has. But it has understood, it knows the barber's number because it is saved on your mobile, and then it makes a call. The other person picks it on the other side. Here is a computer program speaking, audio, voice, something like your Google Assistant's voice is speaking. On the other side is an individual, and he is picked up, and he feels some person has called, because when a phone call comes from a person or from a mobile number, we usually expect a human being on the other side. But here is a Google Assistant speaking and saying that, see, I would like to fix an appointment, and all the natural conversation, right? If somebody says, we respond, something like that, and then that is what it responds. So the other person actually feels that he's speaking with a lady or maybe somebody, and then that whole process is completed, and this thing is booked. Maybe that's wonderful, right? That kind of communication actually happens, and it goes on. So that is actually the kind of test that the artificial intelligence needs to pass, right? So there are, of course, when you look at what is all involved, one is natural language processing, to be able to communicate successfully in any language, maybe English here in this case. But then, of course, there may be other languages also which you want. Maybe in China and other countries, very strict restriction on their own mother tongue. So that's where you see a lot of things. Their keyboard and all also in Chinese. Knowledge representation, to store what it knows or hears. So, and then automated reasoning, to use the stored information to answer questions and to draw conclusions. And machine learning, to adapt to new circumstances and to detect and extrapolate the patterns. So all these things happens. In fact, when you are thinking of that same example of trying to fix up an appointment and trying to find out how it happens, right? So if you want to do that, right? So what actually happens is you try to identify, understanding natural language, somebody speaking to you, but actually it's a machine speaking to you or a software program speaking to you, and then you are able to respond, and you are able to ask questions. It is able to store that question, understand that question, and analyze the question and answer back, right, and give you a reasoning. And then, of course, machine learning can help you do it even slightly better. So why AI became popular is one of the reason is huge data sets. Now, when you look at huge data sets, and why is these days we talk about deep learning and so many things, is because the normal machine learning algorithms are not able to handle huge amount of data. In fact, when you look at big data analytics, right? So big data analytics, you could not store the entire data of a single data set on a single machine. So now you needed multiple machines. So when you have multiple machines, you have a program which has to run on multiple machines. So then you had MapReduce, then you have Spark, which has come in, and huge data, right? So data is now usually computer system will have 1 TB of data. Maybe you have big workstations, maybe 2 TB of data or 4 TB of data, because memory is costly. You can't have a 500 TB of data. It will be costly in that sense, right? So that is something, because 1 TB is 5,000 rupees, so 500 TB will be costly, some 25,000 rupees or 25 lakhs or something. So that's the kind of cost that will be involved. So it will be costly. It's not so easy to get that huge amount of data, and then to store that data also it becomes easy. It becomes difficult because it's costly, right? Though it is cheaper than main memory or RAM or the flash memory or the cache memory and all, but then you can. But nowadays you see people are creating huge data sets, and these data sets are available for everybody. You can download them and you can do the research. Initially, when the data set is getting created, it is for somebody who is doing research. He is creating that data set. And then the second step is many people are creating a library function, a list of functions which work with those data sets. So they're making that library also available, right? And then you can use that library, and then you can create your own modified versions of that, and then you can run it on that data. The second most important thing with the popularity of AI is the computational power. Many of you would want to work on deep learning and all. So one of the aspect is the skill of trying to understand how deep learning works, and how neural networks, and how the CNN and other aspects, and of course all those layers, how to create them and how to manage and all that. Oh, of course, there are so many inbuilt networks now, trying to understand those networks, and by and large, it has become like a component matching. You bring this component, you bring that component, and then run it, and you get some results. And you may get better results, you may get worse results, whatever. Whenever you're getting better results, you say that, okay, I've improved the value and validated it, and then got it. But why is a question which many times we don't tend to answer. So that's a question. So now when we look at computational power, as I was answering, the whole idea is, on one side we try to know and learn TensorFlow or deep learning or all these things, but then on the other side, where are these programs going to run, right? So I need to understand the graphical processing units and the clusters of machines that I can create, and how can I combine them together, and what is multi-core and all. Many times we don't understand the underlying hardware. And when you understand the underlying hardware, then you understand why the coding has to change, right? Why should I not use Python or Java there? Of course, I still use Python in TensorFlow, right? And most of the libraries have Python related versions. But why am I not able to use them? Because it is there's a change in the computational power. So it's not the CPU cores that are running, but I go for the GPU cores, right? So then we were looking at, and when initially I was teaching a course on parallel computing also. So when you look at parallel computing needs multiple threads to run at the same time. So if you need multiple threads to run at the same time, and if you have less number of cores, the threads have to be kind of either do round robin, or you tend to keep it waiting for some time till the job is completed. And then we have various of course all those mechanisms where how to slot it, give priority or shortest process or something like that, right? All those things can be done. But you need more cores is what people try to understand. So then people looked at creating GPUs. So always a question, why GPUs are able to do have more cores, and why CPUs have less cores. So the question that comes is, one thing is constant. What is constant is the heat that is generated. So you have CPUs with more cores, obviously it will be more heat. Now, when you have GPUs which are created, which have more cores, the same heat is generated. So there is a compromise somewhere, right? So if less number of cores, same heat; more number of cores, same heat. Otherwise, if you scale the number of cores and suddenly say that sometimes you have these devices like 3080 Ti, they may have some 2000 cores, right? Or A100 may have 2000 cores. So that's huge number, right? Where we are having 4 cores in a processor, Intel processor, right? So now what can be done is basically the cores, only 4 cores. i7 has 4 cores. In your laptop, if you have i7 and the 11th generation, 10th generation, then you have 4 cores. 4 cores is generating a lot of heat as you touch your laptop, sometimes very hot, right? But then if you look at 1000 cores, now what will be the heat that will be generated? But it's not as much, because there is a trade-off, right? More frequency generates more heat. Obviously, if you have 2.8 gigahertz kind of a laptop, if you have a 2.0 gigahertz, it will be less. 2.8, it will be more. 3.5, it will be even more, right? Maybe you should think what is the big size of these this thing. So you need to understand what is my underlying hardware. Many times we learn only the concept of how the things can run, and I'm very happy about it. But actually, you need to understand why are we learning TensorFlow? Why do we need to run the programs on GPU? Okay, I go for Google Colab. People say that you go to Google Colab, set it up, and then load the data, and then load the program and run the program. But how is the program running? Why is it not running on my laptop or desktop or a single machine or a powerful server in my office, but I can do it on a Google Colab? And then people also say, after Google Colab also, Google Colab allows you to a certain level. You can go after that again. You can't go ahead. So obviously you will have to procure the hardware and start doing it. So when you want to enter into AI, 2 things that you need. You need huge computational power. The first thing is you need the ready-made data sets. If you have a data set, if you have a problem, if you have a data set, and then if you have the resources, I think it's only a matter of how much time it takes for for us to learn a programming language. First time you may remember when you learned C++ or C, then you learned Java, and then you had Python and a variety of other languages you have learned. So how long does it take that cycle is what you need to understand. So two things: one, you need computational power; one, you need huge data sets, and data sets are obviously available these days, and computational power is also available. And then people are also, once they finish their research work and once they finish their publications, they are putting most of these data sets on there. So if you look at where all AI can be used now, when we look at artificial intelligence in education, where a variety of questions are being created now, right? And whenever somebody is writing an online exam, in fact, we were trying to build an online software ourselves for an in-house software development, but unfortunately we could not complete the things on time, because again then we moved to the offline mode of conducting the exams. So we thought it would be difficult, but then the question that was there was, as the student answers better questions, some of the questions, we should be able to step up the difficulty level, right? So there must be an inherent program which is running behind, and it is giving questions, and as the student is responding, he's getting more difficult questions. And if he's not able to solve those difficult questions, next time he's given an easier lot of questions. So that's how we try to look at how things go on, right? So there is also, in fact, if you have understood Coursera and others give you a certificate, whether we don't know whether you have attended any class or not, or whether you have actually attempted the questions or not. But then they have a strong authentication mechanism. They ask you to type 2 or 3 paragraphs when you start. So they know how your fingers are placed. And if somebody else is feeling that same thing, his hand movements will be different, right? The way we do the typing and the way other person does is different. So there is definitely going to be variance. So Coursera founder Andrew Ng used this and then use this, and then he suggested that we can try to look at that aspect, and then he tried to understand that he tried to look at how you can create this mechanism, right? And then he asked them to type a paragraph, 2 paragraphs or 3 paragraphs, and once they type the paragraph, it is logged, right? So all these calculation of these words are definitely done. And next time when you sit in that, it knows whether you are the actual person or not. So there's a research paper related to that as well, right? So then, of course, climate change, e-commerce, a lot of companies do. Many times when you go to Reliance, people ask you for a mobile number, or they'll say we'll recharge your mobile because you purchased so much. Actually, they are trying to correlate your mobile number with whatever you are purchasing. So next time when you come again, they will correlate. So over a period of time, over a period of 5 years, they know what you will buy in which month, right? By and large, okay, you may not repeat many of the things, but then they tend to know that there is a chance that he may be buying. So over 100, 150 customers or 300, 400 customers, they tend to develop what is the requirements and what people are liking, what people are not liking. So that kind of information can be done. Agriculture. Then, of course, lastly, my aspect of intrusion detection that we would like to share. And then, of course, very simple, you all know this aspect of supervised learning. So when you look at intrusion detection, the supervised learning is where you know an attack traffic, right? So you know the class labels. You know that if these are the features, you have an attack vector. If these are the features, there is no attack, right? So if you have both two types, you can have a normal data which is analyzed, and normal data usually that all through the day that runs, and normal data is analyzed. So you can easily find out what are the anomalies, right? So you do what is called rare class mining, right? Then you have a semi-supervised learning, that is you have only for the normal traffic you have the labels, and then you can do semi-supervised. If the labels are available for both normal data and abnormal data, it's easy. That's where you classify it, right? Then unsupervised learning, there are no labels at all, right? So there is no categorization or how you have done it or how it is possible. Nothing can be done. So no labels are assumed. So there is no labels, and hence what you try to do is you try to identify types of traffic, or types of packets, or types of data, and then obviously the normal data will be more and abnormal data is less. So it is not that if you are there in 24 hours and somebody attacker is attacking you continuously for 24 hours, so the entire traffic is attack traffic. Never. So he will try for some time. If you are able to be compromised, he will do something else. Otherwise, he will go to some other system. Right. So there may be an attack on the system, but for a less period of time. So that is the supervised learning, basically classification, and unsupervised learning basically talk about clustering, right? So of course, again, it comes from the data mining perspective. Also, you have classification, clustering, and association rule mining. So I'm just going a little fast. Maybe the metrics here, right? For classification, everybody will tell the metrics. I will show that slide also a little later. But then again, you must also know the metrics of all of the clustering, right? Clustering metrics, most of us don't know. So please look up, right? Clustering के भी metrics होते हैं क्या? That's kind of question that usually is asked. So please go and refer. What are the metrics? How do you evaluate clustering? And clustering is as important as classification also. Just like you build a classifier model, you can build a clustering model, and then it can do the later part, right? Then another branch of science which is called soft computing, as you know, artificial intelligence, neural network, and fuzzy logic. Of course, they tend to combine some of these things. So there were a lot of when I was doing my PhD, there were a lot of approaches on neuro fuzzy techniques, right? So they try to combine neural network and fuzzy logic, right? So they called it neuro fuzzy, right? And then genetic algorithm. There were other aspects called rough sets, right? So these aspects you can try to look at and then try to apply, right? Of course, the nature-inspired algorithms are also there. Variety of nature-inspired algorithms there. We are talking about particle swarm optimization, PSO, the ant colony optimization, bacteria foraging, and there are so many also which are related. Neural networks are all nature-inspired algorithms, but these categories are basically trying to find the kind of mechanism that happens inside, right? And there are variations of these ACO, PSO, and a variety of these functions that are there in the nature-inspired algorithm. So adaptive learning, and then you can look at some of these things, right? So most important as we look at in intrusion detection, it is the metrics. The first level of things that we tend to understand is metrics, because the first level of understanding metrics is to understand false positives, false negative, true positive, and true negative, right? So many times we are confused with if I ask a comparison between what is the difference between false negative and true positive, what is the difference, right? So there tends to be a lot of confusion. So what is false positive and all? So false negative, if you look at it, so please remember the hint that comes is true and false at the beginning, right? Positive and negative at the end. So if you look at it, true means if it was predicted correctly, it is correctly predicted. If it was predicted as not an attack, it has been correctly predicted, it's a true positive. If it is predicted as an attack and it has been correctly predicted, it is true negative, right? So that's a spectacular change that you look at, right? So that you must remember. So if it is a false, right, whether it is false positive or false negative, it is the opposite of what it is, right? So that is something that you need to understand, right? So let's look at the definitions and then again come to the conclusion. See, these are all aspects that form very important because of these aspects of classification and other things, right? So we need to understand these, and then we need to develop a methodology, and it's not very difficult. And I'll just tell you that students also did some simple problems like this, and they were able to get hold of a variety of aspects, right? So let me share with you. So event corresponding to the occurrence of an error that may lead to security failure or security or a security failure that is not detected as such. No alarm is raised, also called a miss. False negative. False negative means there is an error that is happening. That means attack is happening. False means attack is happening. True means there is no attack, right? So true and false are whether the attack has happened or whether the attack has not happened. So it's a miss. That means there is an attack has happened and I could not trace it, I could not detect it. That's what is called false negative. So the event corresponds to the occurrence of an error that may lead to the security failure or a secular failure that is not detected as such. So no alarm is raised, also called a miss, right? So when you miss it, so when an alarm is not raised, there's an attack which happened, but you're not able to detect the attack. It's called false negative, right? You could not detect is negative. The attack has happened is false. Then false positive is event is corresponding to an alarm generated in the absence of an error that may lead to security failure or security fails or a security failure happens, which is a false alarm. Right? There's an event corresponding to an alarm generated. A detection is flagged, but actually attack is not there. So that is false positive. So what we tend to understand is event corresponding to an alarm generated in the absence of an error, right? So there is no error, but an alarm is raised. It's called false positive, right? So between false negative and false positive, what is more dangerous, or what we should look for? Should we look for false negatives or should we look for false positives? Especially with reference to intrusion detection and security. Anyone? Which is more to be watched out as a researcher? What is the one that you must look at? False positive. Very good. So I just don't want to ask questions, but just yeah, this is one way to understand how much you are trying to or how much you are with me in trying to understand. So false positive is more dangerous. The only reason is attack has not happened, but you are raising an alarm that some attack has happened. And if somebody investigates and he wants to find and fix a responsibility to somebody, then he will have to tell that somebody who has not done has to be blamed that he has been done, right? So when you look at general justice also, somebody is not said to be guilty till he is proved. He is only accused. Accused is not guilty till he is proved. So that's a principle that we also tend to use. Most of the times we have situations where there are false positives, but we don't announce it because we want to estimate that, right? So that is the thing. And then if you look at true positive is the correct generation of an alarm. So true positive means the attack has happened. True positive means the attack has been detected properly or the attack has been classified properly, right? True negative means correct decision or not to rate an activity as causing an error that may lead to security failure. So in fact, what has happened is there was no security, there was no attack, but then you have, it was a correct decision to say that the attack is not there. So the attack is there or not there is false and positive. It's positive that we look at. Whether it is correctly classified or incorrectly classified is true and false. True positive and true negative, they are correctly classified. What are they correctly classified? True positive says that attack has happened. True negative says attack has not happened, right? So these two things, that means to say that we understand. So when you go for false positive and false negative, right? False means incorrectly classified. Positive means the attack is there, but it was incorrectly classified. The positive says, or the other aspect talks about that if it is, the true negative, that attack is not there and it has been classified that attack is not there. So this is the metrics of true positive and true negative. And then what do they do? These true positive and true negative help in a lot of other metrics like accuracy, sensitivity, specificity. It's very simple formulas which are there, and standard formulas are there, and then you can easily differentiate between accuracy, specificity, and sensitivity, and then make them combine together, right? And then, of course, there's a confusion matrix which you create, correctly classified, incorrectly classified, that kind of table that you can draw. So that is what, and based on these values only, accuracy, specificity, sensitivity, you can actually draw a RAC curve, right? ROC curve. ROC stands for receiver operating characteristics. So I don't know, this is a kind of electronics term, but then they are used for this thing as well. So ROC curve, and then you have recall, precision, and e-measure, right? So how do you measure that an existing data set which has the the requisite numbers. So you can try to calculate what is recall, what is precision, and what is F measure, right? So these are all the metrics that you can try to understand. Why am I telling all these things? Now, a very simple thing is you take up 5 algorithms, run them on 5 data sets, and measure all these 5 and make a comparative table and send it to a good, or maybe you could send it to any one of those journals which take survey papers, right? Recently, we caught hold of one thing which is called Computer Science Review, right? CSR. Computer Science Review is a Elsevier magazine which specializes on security. Sorry, on what is called it specializes on survey papers, right? So you can try to look at that, right? So there are so many aspects that you can look at, right? So these are the metrics and we need to study. So if I would like to tell you, these are all steps by which I came through. And now today, though I don't write code on machine learning, I can very easily understanding what the machine learning code does. And then if I have to do that, right, so that can be done. So there are a variety of attacks which have happened, denial of service attacks and scanning attacks and user to write privilege escalation attacks. So you have logged in as a user into a network, but then you slowly became a user role. You added that user role. And there's remote to user connectivity was also given. And you have fuzzers. Then you have a variety of these devices like black door, exploit, shellcode, worms, so many aspects. And then there is an important concept called reconnaissance. Reconnaissance is you are there and you are studying a network and then you are seeing how attacks are happened. But before you attack those systems, you are actually doing a reconnaissance, right? You just can try to analyze these things. So these are variety of attacks and people have created. And one of the popular data set is called KDD99, right? When I used it in 2012, when I was doing my PhD, right? So then people said, how old is the kind of mechanism and then the software and hardware? So I was surprised that, very old. So these kind of things you need to understand. So reconnaissance is trying to understand which systems are compromising, who is the owner and how are they joining the network, and all those things can be identified as a attacks, right? So what we did was one of the simple test. What we did was we wanted to apply these machine learning algorithms. Some student wanted to work with me, and they were interested only in working in machine learning. I said, okay, you take machine learning. I also don't know much. So what you try to do is you try to run 10 algorithms. You try to run the 10 different algorithms, and then once you get the results, we can compare. So I want you to get the false positives, false negatives, and then you try to combine the results and then see how it goes, right? So you have a variety of these algorithms using artificial neural network, a decision tree, or maybe different kinds of things. So you have the naive Bayes, you have the support vector machine, it's called SVM, okay? And somebody developed a library for it, libSVM, right? So that is there. And genetic algorithms, K means clustering, K nearest neighbor, KNN algorithm, they talk about fuzzy logic, HMM, hidden Markov model, and then swarm intelligence. So variety of these techniques. So now again, soft computing we have studied, and of course, as we go through the other aspects of going through, we can also find out the remaining things, right? So this is a mechanism which we tend to do. So before I go here, let me share some thoughts about what we did, and then we will come back to understand this, and then we'll take some questions, right? So let me share one important paper by which we tend to look at how we went about, right? So this is this is the paper that I wanted to talk to you about. So here you have, are you able to see the paper? Yes, are you able to see the paper?
Yes, sir.
Yeah, because of this paper only, today I'm able to confidently come before you, because we did a detailed analysis of intrusion detection. Of course, the data set was quite old, because the data set that people talk about is the KDD cup. So there was this knowledge discovery and data mining cup. Of course, now there is a good journal also, KDD, knowledge discovery and data mining. You have it in, I think, Elsevier also. There is a transactions on KDD, knowledge discovery and data mining. KDD, that's the transactions, IEEE transactions on knowledge discovery and data mining. So basically, they look for papers like this where you are able to analyze a data set, apply a combination of algorithms, and try to give you a result. So this paper is basically a detailed investigation and analysis of using ML techniques for intrusion detection. When this paper was written, I think 2017 or 16. I don't think deep learning was very popular at that time. And then it is still coming up. So that is there. So by that time, we had studied all these things. So I had given a simple assignment that, in fact, when she went to Australia, where one of my students was working with Professor Vijay Varadarajan, and then he gave her a lot of these machine learning problems. So what she actually did was she took that KDD 99 data set and ran a lot of algorithms, right? All those algorithms that I showed just now, some 7, 8 algorithms, 10 algorithms, all those algorithms were executed. And based on those execution, you could understand that this is how misuse detection and anomaly detection can be compared, right? And all that introduction. So we went and ran through a variety of algorithms, and based on the algorithm, so we could see that this is the data set KDD 99 and what are the features that are there. So this was available. So we could get this information and then propose the mechanism. And then, we went. So basically, what are the different types of attacks that are there, and what are the scanning attacks, and so many things which are happening on the network. So all these things are there because it's a 37-page paper, right? So then we actually started with techniques in machine learning. Then, as you see, the various algorithms. One is the decision tree. The second one is artificial neural network, right? The third one and all. So you can see this entire paper, which talks about 10 algorithms, right? And then SVM and all that. And then after we looked at all those algorithms, in fact, the whole list that I showed, all those algorithms have been discussed here briefly, right? And then we also talked about ensemble learning, right? Ensemble learning is combining of multiple classifiers together and running. So that is how this thing was running. Sorry, I just did not plug my laptop. Sorry. Yeah, sorry for the inconvenience. So then this whole aspect of going through these all these algorithms, and then also looking at some of these ensemble algorithms where you try to bring in all these decision tree algorithms and then create a random forest, and then you can stack a SVM with a decision tree, or you can do that kind of combinations we did, right? And then why am I showing all this is because these are some things which are very what do you say, approachable problems where you can try to look at, and this is the kind of paper. So we see that different people have applied different machine learning algorithms, and they have got their own different kinds of approaches. So this whole thing, of course, because the survey paper you would have studied. But then what I'm trying to look at, these are all the other techniques that have been there, what features have been identified and all, right? But what is my interest in showing is, 1 minute, let me come to that. I think we are still doing the different types of classification. So just imagine, yeah, this is what I wanted to show, right? So if you look at here, there is a denial of service attacks, and then you can have single classifier with 41 features. Then you take only limited features, then you see the result and the improvement. Then you have multiple classifiers with all the 41 features, multiple classifier with limited features, but it was on one data set, right? So we sent this paper very confidently that we have done a lot of papers were cited, a lot of content was written, a lot of algorithms were analyzed. But then the question that came back to us is, this data set is very old. Why don't you run on more data sets? So we had to go back and run all these algorithms on 2 other different data sets, right? So again, so this was what kind of attacks that were happening. And then this is for a different type of attack, scanning attacks, pseudo attacks. So all these things happened. After that, again, there were more data sets were considered, and based on that more data sets, we try to again work out that whole mechanism, right? So we also got the new and recent some of the attacks that can be handled, because these are attacks which were considered some time earlier. So that's the kind of thing that is there. So what are the future directions and all? So that's the kind of process that happens, and then we could go ahead, right? So, in fact, much before that, if you look at this, while these were 2013 when I was in a private university before I joined MNIT. So we just had this machine learning. Everybody was talking about, but I said I work only in intrusion detection. So finally, what we did was we took some of these algorithms. Let us say we took up top 10 classification algorithms, top 10 algorithms. Professor Vipin Kumar has written a paper by top 10 algorithms in data mining. So we took all these 10 algorithms and took this data set, which was modified. The KDD data set was modified. It's called NSL KDD. We used a simple tool called Vector, right? And then ran all those algorithms, right? Baki, of course, we have written a lot of these things, but there's one table which I've generated: accuracy, specificity, sensitivity, and classification, right? Of course, so when you compare that values, it is really it was a very simple work. But then, as you look at it, there were some 80 citations of this paper already, because ye bhi nahi kara. Then we saw, for some of these values are more, and for usually we are seeing that here red color is the highest. Here we are seeing red is not that highest. So we try to understand what is going on, what are the features that are going on, right? And then you can try to come up with that. So this has been cited 100 times, and this paper is almost, the IEEE Communication Services tutorial is almost coming to be nearby 300 citations, one paper, right? My student's paper, PhD student paper. So about how many, I don't know, more than that, right? So about 167 references in that, and that's where you can see, right? Trying to write that kind of material and all. And then one more interesting area that we tried to do was just combine classification with SVM, and you stack it with various classification algorithms. You take SVM as one input, and then you stack different algorithms and then run the program, right? That's all we did. And some of the MTech students at that time, we came from NITTT at Chandigarh. So they did it. So we just had to come up with all that background and introduction and some of these things, and then we write these table. We generate this table. So SVM, if you run alone, what will happen? And then you have along with bias network, along with ADA boost, along with logic regression, and 10 attire and all that things, right? Random forest, JRIP, 1R, and all that, and then you get the accuracy, specificity, sensitivity values. Now this will, because anyway we have studied accuracy, specificity, sensitivity. These are the formulas that we have mentioned, right? And then we have shown those diagrams as well. So this was very much attainable, right? And if you look at this paper, this is now 300 citations almost. So maybe in another 1 week I'll be reaching that citations. So these are the two papers where we are simply trying to cast we can do that, right? So that's something that we can try to understand, right? So let me I think and then towards the end I'll come back and show our dissertation aspects, right? So we'll come back again, right? So let me go back to my slides and conclude, and then we'll come back for any questions, if any, right? So as we look at again, we see these are the algorithms that we tend to do. So decision tree, ANN, naive Bayes, SVM, genetic algorithms, K-means, K clustering, K-means clustering, neighborhood, and nearest neighbor, right? So that's one thing. And then fuzzy logic, hidden Markov models. So all these were implemented by us, and we could get the results, and not only for one data set, but for multiple data sets. And then we could actually make a comparison and then give a conclusion as far as intrusion detection is concerned, because many people have written on intrusion detection, right? So these are the algorithms that we had studied. Similarly, the top 10 algorithms were there. They are different types, and then we could get this kind of. Then you have ensemble algorithms where we combine multiple algorithms. So many times people have worked on machine learning, and when I've asked what is ensemble learning, many have not answered. And I don't want you to be like that. now you know what is ensemble algorithm. You try to combine 2-3 algorithms together. That's what is an ensemble. In fact, people use the word multi-classifier for a long time, but then again, multi-classifier or multiple classifiers, that becomes a question whether what is multi there, right? So that's where you have. So some of these examples are stacking, which we have seen, stacking SVM with all the machine learning algorithms. So they are understood. So similarly, voting is many times people can control the way that they are trying to manage this, right? So you have boosting, you have bagging, you have majority voting. So all these things are put to use, and then you can try to look at, right? So that is one more aspect, right? So then you have another important aspect which intrusion detection helps. Not only does it analyze, if you have class labels, it can very easily analyze and find out what kind of attacks were there. It can find out when the attacks happened. It can also find out who attempted those attacks. But when you look at it, the machine learning also gives you an important aspect called feature selection. So again, feature selection is also based on an algorithm. You don't have to handpick the features, right? So when I finally understood all these aspects of machine learning, so I told finally we don't have to do anything, is it? Everything machine only will do it. So first you load the data set, it will tell you which features to analyze. So then select all those features, create a new data set, and then run your algorithms on that data set, right? And then we don't understand what the actual algorithm is doing, right? How is it remembering those values? How is it identifying those values, right? Maybe it may be slightly different and costlier in that sense. So how it can be done, right? So now the feature selection is also done. So there are variety of methods. So we need to understand. It's very easy to run the algorithm, because later I will talk about the tools also. Some of you may be using the tools, and I am sure that Dr. Pooja Jain would have actually given you some hands-on exposure on with the tools, and then you would have ran some codes and understood that. So that's a single classifier with limited features, and then you can also have multiple classifier with limited features. So that basically the reduction is what you're looking at. So there's a data reduction problem. There is some of these issues are there, so you can try to look at that, right? So there's a you consider all the features and run it with single classifier. So there were all these options were there in that paper. If you would have you can also read that. So you can have with limited features, obviously it'll be faster, right? If you do some 100 features, that is 100 attributes in a make file, and then it may take 1 or 2 days. But then if you run it with few features, it may take less than half an hour. Sorry, less than 6 hours maybe, right? If it was taking 2 days, it will take 1/4 of the time, right? Maybe if you take 10 hours, now it will take only 2 or 3 hours, right? So that's the kind of training that is obtained. So you can look at multiple classifiers with all features again. Again, with all features, it will take more time. Multiple classifiers will take more time to converge. So that's also a disadvantage. But then, yeah, people are doing that, and more this thing. This is a multi-classifier. Multi-classifier, what you do, you send the, you have some 3 diverse methods, 3 classifiers. You get that same input is given to all the 3 classifiers. The 3 classifiers, whoever gives the first one, whoever gives the best one is said to be considered as the architecture part for that time. Right. Similarly, you can cascade multi-classifiers. You can run one classifier after the other, so it becomes multi-classifier, and then you can see the data output as well. Then you have parallel classifiers. The first and the last are you can do that as well. That is parallel classifiers, right? So then you can have a hybrid classifier, which is parallel also, and at the same time sequential also, right? So that's something you can do. So then later we try to look at this variety of algorithms which have come, and we could do that, right? So the major success factor was that the thesis that was produced with intrusion detection in the cloud environment. And later many people worked on intrusion detection in IoT and similar aspects like that, right? So that is something. So if you let me just share one thought with you before I conclude. So we'll try to look at the 3rd chapter where the framework is created, right? There are so many attacks that are there. and then you tend to you can try to use it and that. So this is the kind of mechanism that we have created, right? So we created what is called intrusion detection system, or IDS, and then you have these mapping mechanisms here. So you have the VM introspection level, malware detection. So we had various techniques in cloud. We want to do intrusion detection in cloud. And one of the challenge I gave the student at that time, right? It was very difficult for her to digest, but it was good enough that she could try that, and we got the results. Many times we don't take challenging problems. We want the problems to be easier. We want the time to be less. So at the end of the day, we are compromising our own quality. Even if one paper is there, it is sufficient. This girl could produce 5 research papers by the time she completed her PhD. And I'm happy to tell you that the book on these intrusion detection in cloud you can talk about, or it is actually cloud security book based on some of the concepts of these papers and her thesis. She has published a paper, published a book by Taylor Francis on cloud security. So what we did was we tried to propose a mechanism called cloud hedge, and cloud hedge has mechanisms at various levels. But because it was cloud, I had a question, because everybody was applying machine learning on cloud, data or attacks on cloud, but they were not exactly attacks, because cloud and a network, cloud is actually a network. So if you are launching an attack on a network, you are actually launching a network security attack. So it is not a cloud attack, it is a network security attack. I have to be strong and I have to give you those this thing. So here we have this 3 mechanisms. So I told her it will be cloud security only when you cross the most defining factor which differentiates networks from cloud. So it so happened when we are looking at intrusion detection, I told unless and until you cross the virtualization layer, which is not there in networks. In a normal network, virtualization layer is not there. So unless and until you cross the virtualization layer, I can't consider it as cloud security. I will consider it as network security only. So then she went and sat on that cloud, and then that's where we try to look at the cloud, in the sense, of course, we tried to set up a cloud, which was not possible, but we set up what is called a hypervisor, or kernel virtual machine, or Zen server. These are some of the names, but the hypervisor is the generic name. So we set up a hypervisor, which is the core component, the heart of like how kernel is for OS, the kind of this compute machine is for the everybody, right? So you need to cross that hypervisor layer, and then so we created some accounts. After we could understand, we got some procurement, and not much, but then yes, we could do something, and we could come to the conclusion, right? Most of the things were there. So and then we proposed one collection aspect at this thing, and the second aspect at so one aspect which was called MSCSD was working on the virtual machines, right? The second virtual machine is running at this network layer. This is the MNPD, right, at the network layer. This thing. So there are two more papers, VAED or VM Guard. VM Guard is the paper that Dr. Pooja was mentioning about the IEEE transactions on cloud computing. So we have that paper sitting there, right? So VM Guard, it's a transaction paper. So you can read that. In a lot of machine learning, a lot of this thing has been run. A lot of Python codes are run. Of course, if you're free, you can contact her. So we look at this whole network, right? If you look at this, an OpenStack environment, right? So now what I'm doing, I am giving you a case study of how to apply machine learning to a different domain. First, you have to understand the domain, understand where machine learning can be applied in that domain, right? How does it solve your problem? For me, I wanted to do intrusion detection. I wanted to find out what are the attacks that are launched, but somehow, right? But still we could put something together. So on a live cloud environment, we wanted to launch the attacks, collect the data, and then analyze the data. But then, after reading a lot of literature, we came to the conclusion that it's easy to work with the data set and then it's easy to work on the hypervisor, and then we can get that. So we got some data from the hypervisor. Then we saw how does the data look like. Then we took another example, another data set which was similar looking. So obviously it was not a cloud data set. So let me be honest with you. But then we said if a classifier can be built for this hypervisor, a classifier can also be built by another hypervisor. So that's how we were trying to look at. Now, many times when the students come and they were about to go and take the thesis and signature, so then I remind them about the future work. There's so much of work that has to be done. So that is something which is a challenge, right? So this was how these three networks were maintained, and this network was fetching the whole thing. So this is something that will happen, right? So let me go back to myself. These are the papers. This is the thesis, and then various papers you can refer, which will try to understand that it has been worth this thing, right? After this thing is over, then let me go back to the slides and conclude, and then I will take some questions, right? So yeah, so this is the multi-classifier. You are trying to build a hybrid classifier. Then multi-classifier by input values only, where the features extraction is directly doing, and then multi-classifier based inputs which are coming to every level to our main repository of the features that are there, and then we can try to come with a conclusion. And obviously Veka is the tool, but then there is scikit-learn, which is quite popular now. And then of course we are looking at deep learning. You will go with the TensorFlow. Similarly, you have proprietary software, which is KMI and RapidMiner and SPSS. So these are the tools that you can try to get hands-on, and then you can try to make a comparison of that. So this we have discussed. So I would like to stop here. I'm not an expert on machine learning or deep learning, but then I have applied deep learning mechanisms, autoencoder mechanisms. So for me, it's a black box. What happens inside, I'm not concerned, because you guys are doing it well, or maybe the students are doing it well. But what is the input and what is the output we observe, and what is the cost difference that is there. So we tend to analyze these whole systems, and then try to come to that, try to make that common mechanism, and then we can try to look at how it goes, right? So the challenge that is there these days is we get the data sets, we know the tool, but we don't run the algorithms. That is the very unfortunate aspect. In fact, I was asking my student when she was picking the values, I said, where are you getting these values from? Did you execute the programs? No, sir, wo log already kar chuke, so I'm taking their values. But I said, why not you run it? Because we don't know whether they did it correctly or not. Right? In some cases, she found there is an error of the timing that is there, and how much they have shown as accuracy. But it was their values, and they published it. So many times we can check. So where you can start, right? You can start with picking up just some 10 modern algorithms now. Don't even take the ones that I took. So you take some 10 new algorithms, take a simple data set, and run data on all of them. And scikit-learn is a very simple tool. So it will hardly take you 2 minutes to understand if you want to go and do something. So that's the question, right? So these are things that you can try to understand. I think my time is also coming to a close. So I'm open for taking any questions. I wanted to give you confidence, because many times we struggle where to start, what to do with machine learning, right? You start simple with a small data set, start with scikit-learn, start with Veka, start with the TensorFlow, and then run it. Start with Google Colab. You don't get a GPU, no problem. Start with Colab. Run the things, and then slowly, once people know that you're able to do this, you will be able to get the resources from other sources, right? And then you can try to do it with or without the resources. So to some level, you can easily do it. But without doing, we will all start saying that if these resources are there, if this training is given, then I will start. Then I don't think you will end up anywhere. So I just said all these things because just by ideas, students have got good papers, and they've got good dissertations, and they are now well placed also, because they did a lot of work. We can do something very innovatively, come up with a new machine learning algorithm, or we do routine, what I would call it, donkey work or gadagiri, but we do a hectic work, do so much of work, that it speaks of the volume, and then because of that also our work get accepted, right? So, and then we can look at this that 37-page paper that I'm talking about, detailed investigation. It is now got about 295 citations, and its impact factor is about 25, 24 point something, right? So that's a privilege, and now it motivated my student to write one more paper. Now I am yet to review that paper. It is on IoT botnets, and another 30-35 pages she has developed, right? So I have to write it. I have to review it and submit it. Hopefully it may come. So that's the kind of thing. And then this kind of papers later become a textbook. So that's something that you can look at, right? So I want you to get hands-on, and it's not difficult, and it's not. You just need Python, and you need a little bit of understanding of machine learning and kind of these algorithms that are there, and then you can start. Yeah. Over to you, Pooja.
Thank you, sir. Thank you so much for giving the insights on machine learning. You say you are not an expert. I don't agree. You are an expert of machine learning. So don't say this, you are not an expert. You are using machine learning since very beginning. So you are definitely an expert on machine learning, and you are speaking so much on all these topics. So how can you say you are not an expert?
Yeah, what I would say is I myself don't have hands-on, but usually the students do all the coding and all, and
that happens
I do
when you come to the
box.
stage which you are. You don't do it actually. You don't have time to do it. You will manage the department, or you will write the code.
Correct. So it is for me, it's a black box, but I know what is the input and what is the output to be expected. I think that is what
True.
matters.
Any questions that anybody would like to ask? And sir has also shared his email ID with you, so you can drop in the questions, and if you have, you can just ask right now. Any questions that you would like to ask? No? Actually, your talk was so easy to understand, so simple to understand. There are no further questions.
Right. One thing I would like to help you is recently I reviewed a paper where that paper put up a list of so many data sets on network security. Right. It was where all the data sets are available, and where can you download it from. Right. So very simple. Just go to Google and search the data set, and then you can download it, and then you can write. So on network security. So I can send you that. Maybe the paper has already come online now. So I can send you that paper.
Sure.
I can send you this detailed investigation paper also, which you can share with the participants.
Sure. Please share it with me. I'll share it with all the participants. Thank you so much. Thank you. It would be a great support. Thank you, Pilli sir. You have never, you have always accepted my invitation whenever I say so. So thank you so much for always being a very good friend of mine. Thank you so much.
Okay.
Thank you all the participants for joining for today, and for tomorrow we will start at 9:30 usual time. Thank you, Pilli sir, once again.
Okay.
Thank you. Good evening. Bye bye. Please do keep sharing your feedback and your attendance, because that is very much required for the certificate generation. So I hope everybody has that link, and you can also take the link from the WhatsApp group. And I hope the workshop is going on cool, and you are understanding the things which the different experts are mentioning. And today also all the lectures were very useful and important. Dr. Jitendra, Meenakshi ma'am, all. Okay, so you want the link? I have already shared it on the WhatsApp group. I am again sharing it over here on the chat box. Just hold on. Yeah. I hope you people are getting a lot to learn from the different experts. I would like to have a feedback from you on the chat box if it is possible, whether you are liking the sessions or not. Because I mentioned in the very first day that I have taken a lot of pains in calling the people from different parts of India to really give you the insights on different types of problems. Actually, he talked about confusion detection. In the morning, we talked about skin cancer detection. Tomorrow, we'll be dealing with lots of biomedical applications by different experts. And it will also be a very helpful session. And the last day would be on natural language processing. So I have tried to cover most important domains of machine learning and deep learning, so that you get an idea in which you can do research, and write papers. So thank you once again for all the inputs. Thank you, Sadhana ma'am and Nisha ma'am and Suman ma'am. Thank you if you are liking the workshop. Thank you. Okay, bye-bye. Take care. We'll meet tomorrow at 9:30 with Dr. Jitendra's session. And tomorrow after Dr. Jitendra, there will be 3 different people talking about 3 different problem solutions using ML and deep learning. Please don't miss them. Because nowadays biomedical domain has come to a very important phase and people are working a lot on biomedical domain. So please don't miss those sessions. Thank you everyone. Bye-bye.